this video, we're going to get into chapter number 11. And so here we're going to be talking about the angular momentum. So angular momentum is the momentum of an object that is moving in a circular orbit. So if you remember, we introduced the linear momentum, and we said that the linear momentum is just given by the product of the mass of an object and its velocity vector. We also said that the force can be represented in terms of the change of the linear momentum with respect to time. And we said that whenever the external force is acting on the system is equal to 0, this means that the change in momentum is equal to 0. So it means that the total angular momentum before must be equal to the total angular momentum after. And that was called the law of conservation of momentum. So here we're also going to introduce the angular momentum. Then later on, I'll show you how the angular momentum is related to the torque. And then we're going to see that whenever you have a system where there is no external torque acting on the system, then this means that the angular momentum before is always going to be equal to the angular momentum after. And this is called the law of conservation of angular momentum. All right, now let's introduce a quantity that is called the vector product and torque. So generally the torque vector can be written in this form. So the torque vector is just the cross product of the displacement vector and the force vector. So if you look at this picture right here, so suppose that this is my x-axis and this is my y-axis and this is my z-axis right here. Now if I have a point P such that the position vector from the point O to the point P is r, and suppose that we apply a force such that the force makes an angle phi with respect to my displacement vector, then I can calculate the torque using this cross product right here. So the cross product of two vectors gives me a vector. So because my displacement vector is in the xy plane and my force is also in the xy plane, then when I calculate the cross product of the displacement vector and the force vector, I get a vector that is at 90 degrees with respect to the xy plane. It means that it's pointing in the z direction. Now the magnitude of the torque is just given by the magnitude of the displacement vector times the magnitude of the force times the sine of the angle between the displacement vector and the force vector. So again, if you remember, we said that I can take this force and break it into x and y. So I can write this force in terms of a component that is pointing in the direction of the displacement vector and one component that is pointing at 90 degrees with respect to the displacement vector. So we said that whenever we calculate a torque, we only use the component that is perpendicular to the displacement vector. That's why the magnitude of the torque, we need to use the sine, because if you take the cosine, so the cosine is going to be pointing in the displacement vector, and then the sine is what is going to be at 90 degrees with respect to that displacement vector. So generally, we can introduce, so suppose that we have two vectors A and B, then I want to calculate a new vector C that is given by the cross product of vector A and vector B. So as you can see right here, if this is my vector A and this is my vector B, and let's suppose that there is some angle between vector A and vector B, then when I take the cross of A and B, I get a vector C that is pointing in this direction like that. So basically you can use your right hand, so you can use your right hand to get the direction of vector C. So basically what you do is that you place your fingers. So you place your fingers in the direction of vector A, and then you simply curl. So curl all your fingers in the direction of vector B, then your thumb is going to point in the direction of vector C. So you can see that, so what you can see here is that the magnitude of vector C is going to be just the magnitude of A times the magnitude of B times the sine of the angle. But the direction is pointing up. All right. Now you also want to notice that if you were to do this the other way around, so if you do B cross A, then you simply get negative C. So A cross B is equals to C, B cross A is equals to negative C. And you can also see this. So if you want to calculate B cross A, so what you're going to do is that if you place your fingers in the direction of vector B and then you curl them towards vector A, then you're going to see that your thumb is going to be pointing down. I think the easiest way to understand this is that you want to remember that counterclockwise is always called the positive direction. So notice that if I start from A, so going from A to B, I'm moving in the counterclockwise direction. So A cross B is C, is pointing up. But if you do B cross A, so going from B to A, you're going in the clockwise direction. And so B cross A is going to be negative C. So that's something that you want to remember. So counterclockwise is positive, clockwise is negative. All right. So these are some properties of vector products. So generally, A cross B is equals to negative B cross A. So give me any two vectors, vector A and vector B, then A cross B is going to be equals to negative B cross A. Now, if you take the cross of a vector and itself, so for example, if you do A cross A, then you get 0. Now, also notice that if A and B are at 90 degrees, so if A is perpendicular to B, so if vector A is perpendicular to vector B, then the magnitude of the cross product of vector A and vector B is just going to be equals to the magnitude of vector A times the magnitude of vector B. Now, if I have three vectors A, B, and C, then if I add vector B to vector C and then take the cross product with vector A, I can write this as cross product of vector A and B plus cross product of vector A and C. Now, if I take the derivative of the cross of A and C, then this is the same as the derivative of A with respect to time cross B plus A cross the derivative of B with respect to time. So these are some properties that you just want to be aware of. We're going to use this a lot to solve problems in the homework. All right. So generally we can introduce these basic unit vector definitions right here. So if my I is the unit vector in the I direction, J is the unit vector in the so I is the unit vector in the x-axis, along the x-axis, J is the unit vector along the y-axis, and K is the unit vector along the z-axis. So basically, if you take the cross product of vector I and itself is 0, J and J is 0, K and K is 0. Now, if you take I and J, this is the same as negative J and I, which is K. If you take J and K, this is equals to negative K and J, which is I. And if you take K and I, this is the same as negative I and K, which is equals to J. So generally, the cross product of A and negative B is the same as negative A cross B. Now, again, you can remember this very easily. So if you move in the counterclockwise direction, so again, if you go from I to J, you get K, and then you do J to K, you get I, and then K to I, you get J. Now, if you move in the clockwise direction, so instead you're doing J cross I, so for example, J cross I is going to be negative K, and J cross K is going to be negative I, and K cross I is going to be negative J. So this is some basic definitions that you want to make sure that you remember. Now, the vector product can be calculated using the determinant of a matrix. So if you give me two vectors A and B, I can calculate the cross product of A and B using this definition right here. So we can write it in terms of these components. So if you know if vector A has components, let's say AX, AY, and AZ, and vector B has components BX, BY, and BZ, then I can calculate the cross of vector A and vector B using this equation right here. So it's just given by AY, BZ minus AZ, BY in the I direction, plus AZ, BX minus AX, BZ in the J direction, plus AX, BY minus AY, BX in the K direction. All right, so now let's talk about the direction of the torque vector. So if this is my x-axis and this is my y-axis and I have my z-axis pointing up, so the distance from this point to this point is my displacement vector at point P, and there's a force that is applied to point P right there. Then when I calculate the torque is just going to be pointing up. So again, because my displacement vector is in the xy plane, and my force is applied to point P, my force is also on the xy plane. And then when I calculate the torque, I get a torque that is simply pointing in the z axis. All right. So now we're going to look at example number 11.1, and this is called the vector product. So in example number 11.1, so what we're going to do is that we're going to calculate the vector product of two vectors. So suppose that we have two vectors that are lying in the xy plane, and they are given by vector A is equals to 2i plus 3j, and vector B is equals to negative I plus 2j. So we want to calculate the cross product of vector A and B, and verify that the cross product of A and B is equals to negative the cross product of B and A. Now, let's take vector A cross B. So when I take vector A cross B, I just rewrite everything like this, and then I can take the terms. So for example, I take I with negative I. So basically, you're just distributing everything. So if you take I and negative I, and then you take I and J and I. So if you distribute all of these terms right here, and then since we know that I and I is 0, so I and I is 0 right here. I and J is equals to K. J and I is equals to negative K, but again, there is a negative sign here, so you end up with a 3K, and J is equals to 0. So if you do that together, you get 7K. Now, if you do B cross A, and you do the math correctly, you end up with negative 7K. So you can see that B cross A is equals to negative A cross B. Now let's look at example number 11.2. So in example number 11.2, we're going to calculate the torque vector. So we're going to calculate the torque vector if we know what the force vector is and if we know what the displacement vector is. So again, we know that the torque vector is just given by the displacement vector cross the force vector. So again, if you substitute everything in here and you carry out this calculation, you end up with this quantity right here. Now, because I cross I is equals to 0, it means that this first term gives me 0. I cross J gives me K, so this second term simply gives me 12K. J cross I gives me negative K, so this term gives me negative 10K. J cross J is 0, so I have a 0 here. And so if you add all these contributions, you have a torque of 2.0 Newton meters, and this will be pointing in the K direction.